Okay, good morning, everyone. We are just waiting for our guest, Gabe, to hop on here. Thank you so much for joining in this morning. Just give it a few minutes. Just a couple of things as we're getting started, some little administrative tasks, questions. I definitely want you to have the opportunity to answer questions. But what we're going to do for the sake of the presentation is we're going to let Gabe share what he wants to, and then we'll do our Q&A at the end. In most Zooms, you might see that you can type the Q&A into the chat feature. We're not going to do that. There's actually a little handy Q&A. It's got, well, hopefully on your screen, it has two little quote bubbles. We're going to use that to ask Gabe our questions. So if you have questions, again, please hold. And for those just coming in, we're just waiting on Gabe. It says he is in the waiting room. One second. I do not see him. Hmm. Gabe Brown. All right, got him. Here we go. A panelist.
Okay, can you hear me?
Gabe, are you with us?
I'm here. I don't know why my camera should be on.
Okay. Talking permitted. Let's see. I'm not able to hear you. Okay, you're going to rejoin as a panelist. Okay. All right, Gabe, I just need you to turn on. There you are.
There we are.
Hi, let's see. I can't.
How are you?
I'm good. How are you?
I'm fine, thank you.
Thank you for being here this morning. I am so excited. I think of all my guests, this might be the talk I was looking forward to the most. Seriously.
Oh boy, you say that.
No, it's for real.
Well, it's very kind of you. It's great to be with you today.
All right, excellent. So just a reminder for anyone just joining, we have Gabe Brown today. He's the author of one of my favorite books, Dirt to Soil. If you have questions, we're going to ask that you just hold them until the end of the conversation. And rather than type them in the chat box, there's two quote bubbles at the bottom of your screen. That's the Q&A feature. That's where we will be running through all of the questions. So Gabe, with respect for your time, let's dive right in. I have like 1,000 things I would love to talk to you about.
Have at it.
All
Have
right.
at it.
Okay. So I think my first question, and you point this out in your book quite a bit, is it's hard for people to believe that you can really regenerate any type of bad soil. And you kind of talk about how when you go and speak at these conferences, you have people that like to challenge you on that, whether they have sand, clay. Can you talk a little bit about that?
Sure. So it really is not very complicated. And one of the things that I do now, I travel around. I have the good fortune, I travel all over the world. I'm on hundreds of farms and ranches, gardens, orchards everywhere each year. And people always say, but Gabe, you don't understand, my soil isn't like that. So we take a spade, a shovel, and I say, well, let's take a look. And we go out into their field or into their pasture, whatever the case may be, and we dig up some soil and we look at it. But then I walk over to the fence line, the road ditch, a more undisturbed site. And by undisturbed, I mean not only necessarily less tillage, but also less intervention with synthetic fertilizers, pesticides, fungicides, etc. And we dig up that soil. And I have never, ever had it fail me yet, where the undisturbed site isn't significantly better. And better, what do I mean by better? Well, in terms of aggregation in the soil, soil should look like dark chocolate cake. It should be dark in color, almost approaching a black type color. That's the carbon in the soil. And then it should have that aerated appearance where there's a lot of texture to it. That's what allows the water to infiltrate. Now we need to talk about how are those little soil aggregates formed. All a soil aggregate is sand, silt, and clay particles held together by glomalin from mycorrhizal fungi and biotic glues from soil biology. So everyone's soil is either sand, silt, or clay, or fractions thereof. So if they don't have well aggregated soil, and I often tell people, compare it to marbles in a jar. Okay, you fill a jar with marbles, that's what, and think of those soil aggregates as the marbles. Well, those soil aggregates only last about 4 weeks. And then biology consumes the carbon, the sticky substances that hold that together. So you have to constantly build new soil aggregates. Now, how are soil aggregates formed? Living plants. Living plants take in CO2, other compounds out of the atmosphere. Photosynthesis occurs. They use part of those carbon compounds for growth. The rest of it, they translocate to the roots and exude that out into the soil where it's consumed by biology. And that biology then, that rhizosheath along those roots of a plant, if you pull a plant up, you'll see all these little soil aggregates being formed along the roots. If you don't see that, you don't have very good life in your soil. So that's how come I can be so confident that no matter where you put me in the world, you can put me on a beach, a sandy beach, I can still grow soil there. It's still going to be sand, but we can start adhering soil aggregates together there.
So I love how you phrase it as growing soil, because even if it's something that you don't already inherently have, it's something that can be generated by nature's design, correct?
Yep,
Okay.
that's exactly right.
Why do you think that building soil matters?
Well, it matters to everything for many reasons, okay? Number one, we need it for the carbon cycle. Right now, we have way too much carbon in the atmosphere. No matter where I travel all over the world, approximately 50 to 75% of the carbon that was once in the soil is now up in the atmosphere. We need to bring that down for obvious reasons, put it back in the cycle. And it is a cycle because biology consumes that carbon. And it's the biology eating that carbon that the plants exude. The biology running its life cycle provides the nutrients to the plant, okay? Makes it available to the plant for the plant to grow. And most people do not realize that any living plant, you have a living plant right behind you there, 95 to 98% of what that plant needs to grow from a nutrient standpoint comes from the air, from the atmosphere. It doesn't come from the soil. We often think as gardeners and farmers, we have to go fertilize in order for that plant to survive. That's not true. You know, before we started this practice of synthetic fertilization, how did people grow plants? Well, it was the natural nutrient cycle. So we need to get back to that. We need to get back to that. And in order to have biology, you have to have aggregated soil, because biology in the soil lives in and on thin films of water in the pore spaces between those aggregates. Again, think of marbles in a jar, pour water in it. The water between those marbles, that's where the biology lives. If you don't have well aggregated soils, you're not going to have water, and you're not going to have the biology necessary for the nutrient cycling.
You touched on this a little bit. You were talking about carbon, and you were talking about how at this point it's all, or most of it, much of it, I would say, has been re-released into the atmosphere. Talk about, for those who might not know, the importance of carbon within soil ecosystems, if you would.
Yeah, so carbon, all life is carbon, everything. You know, us as human beings comprised percentage of carbon. Okay, so carbon is life. You have to think of that way. Plants are carbon. We need that carbon in the soil to feed biology. Biology feeds nutrients to the plant. Plus, the carbon out of the atmosphere, through plants take it up through their leaves, photosynthesis occurs, that's carbon. Carbon drives the whole system. Think of it as the monetary system of ecosystems, more or less, because you have to have carbon. Oftentimes today, people talk about climate change and they think of carbon as a bad thing. Boy, if it's a bad thing, we wouldn't be alive as humans because we're partially carbon. Carbon is a good thing. What's bad is we have way too much in the atmosphere, not enough back in the soil.
And the way that we can absorb it back into the soil is through plants. Correct?
Exactly.
Correct.
Exactly. Okay. That's why, you know, we hear today about many of these schemes to quote unquote sequester carbon. We're going to take it and pump it into the ground. All we need to do is grow living plants, and we'll mitigate this quote unquote climate change.
I agree. I couldn't agree more. That brings me to your 5 principles of soil health, which absolutely has to do with plants. You want to go through those real quick for those who haven't read your book?
Yeah, and first what I'll talk about is there's 4 ecosystem processes that no matter where we are in the world, those 4 ecosystem processes take place. One is the energy cycle, photosynthesis through plants. Number 2 is the water cycle. You know, we have to be able to infiltrate water into the soil, store it there. Okay. Number 3 is the nutrient cycle. And I talked about that, how biology running its life cycle provides the nutrients for the plants. And the 4th is what we call community dynamics or biodiversity. We need biodiversity. So there's those 4 ecosystem processes. Now they're driven by the 6 principles of soil health. We added another one since I wrote the book. So those 6 principles drive the 4 processes. And those 6 principles briefly are: number 1, context. You have to operate within your context. Here I am in North Dakota. I tell people there's a reason bananas don't grow in North Dakota. They don't fit our context climate-wise. We only have 110 frost-free days approximately a year. So you have to grow plants and raise animals within your context, your ecological context where you're at. The second principle is least amount of disturbance possible. That could be mechanical disturbance from tillage, like you rototill a garden. Worst thing you can do if you're trying to produce nutrient-dense food. Okay. It can be a chemical disturbance, such as our fertilizers or pesticides, etc. So we want to minimize and preferably eliminate those. Third principle is armor on the soil. You should never see bare soil. And I tell people, walk into a healthy forest, walk out into a prairie ecosystem. You're not going to see bare soil. Bare soil only occurs because of mankind's actions. Okay. We need that soil cover to prevent wind erosion, water erosion, and to feed macrobiology. Okay. The 4th principle is that of diversity. Nature doesn't operate with monocultures. It abhors a monoculture. It wants a diverse array of animals, insects, plants. So we need to make sure that happens. Oftentimes today, you look at our agroecosystems, they're monocultures: corn, soybeans, wheat, cotton, whatever the case may be. That's not the way nature functions. Okay, the next principle is living root in the soil as long as possible throughout the year. So often we see farm fields where the farmer grew a cash crop, but then it sits idle till the next year. Well, how is that biology being fed if there's no living plants? We need living roots in the soil as long as possible throughout the year. And the final principle, the 6th one, is that of animal and insect integration. nature does not function properly without animals and insects. We've removed the animals from the landscape. We put them in these confined animal feeding operations. No, they need to be back out on the landscape because that's natural nutrient cycling, and there's synergies that take place when we have animals and insects on the landscape. So those are the 6 principles that drive the 4 ecosystem processes.
Was the new principle you added the context one?
It's context, because we added that one, and I give Ray Archuleta credit for that, in that you have to work within your context. Where's your environment? What's your ecological context? We all have different amounts of moisture, sunlight, humidity. We all have different financial contexts, My financial context today is a lot different than it was 40 years ago, okay? We need to work within our financial context. And what we've found as we work around the world helping others move down the regenerative path, that context is just vital to their success. So we added it as a principle.
Okay, my mind is just, we have so much we could talk about. The phrase animal soil nutrient cycle is something you refer to a lot in your book, and it's something that I try to repeat as much as possible, especially when it comes to agriculture and cattle, which you have. We hear a lot about how damaging cattle are, and I think that can be true on mismanaged farms. Cattle and other livestock, when properly managed, rotationally grazed, are actually a solution to the carbon problem. Do you want to talk about that a little bit?
Sure. And the way I often address this subject, people say, oh, cows are damaging the environment. We got to get rid of the cows. So I ask them this, if they're from North America here, best estimates, pre-European settlement, there were more grazing ruminants in the form of bison, elk, deer, bighorn sheep, etc., than there are cows on this continent today. Okay?
Interesting.
If it's true what people are saying, cows are damaging the environment, why weren't those animals damaging the environment? So you see, it's not the cow that's the problem, it's the how. In other words, it's just what you said, how we take care of them. Okay? On our ranch, we have a 6,000 acre ranch here in North Dakota. The animals are moved daily throughout the growing season, a little less often during the winter, but even now, here we are in February, they're out grazing. Okay? There's an interaction. And people say, well, cows emit methane. Yes, they do. But what nobody talks about in natural ecosystems, there's methanotrophs and other free living bacteria that consume that methane. Those methanotrophs live near the soil surface. When a cow is grazing, emitting methane from her mouth, those methanotrophs are consuming the methane. And methane is a gas that's very quickly broke down in the environment. It really does not pose an issue. It's so where methane becomes an issue, where animals become degrading, is when we put them in large confinement operations. Okay,
Like a feedlot situation?
that's like a feedlot situation. That's not good. And then people often come back and say, yeah, but if we take them out of there, there's not enough land. There's plenty of land to take all the animals in confinement out of confinement, move them out onto the land. We can still grow all the crops we need. We can still raise very nutrient dense, and proteins that are much better for us. Okay. So it's not the cow, it's the how. We just have to change the production model.
So one of the themes that run through many of your presentations and through your book is the importance of cover cropping. and not just going through and putting through one triticale or a ryegrass.
Mhm.
And you spoke about this just a few minutes ago. It's to mix as many cover crops as you can essentially afford to do. Um, can you talk about that a little bit? Explain your
Yep.
reasoning and why folks might want to start mixing their cover crops.
Yep. So first I'll say this. The best cover crop possible is a diverse perennial mix, because perennial plants are deep rooted. Now, let's get into a garden situation or a crop situation. There it's different. We're not going to have perennials, but we want to grow our vegetables or our cash crop. But then remember the principle, two of them come to mind: living root in the ground as long as possible throughout the year, and biodiversity, a diverse array. So I tell people this, you don't need to mix 100 species, okay? What we find is if you can get 7 to 10 species, primarily grasses, okay? If you look at native ecosystems, walk into native prairie ecosystems, approximately 2/3, 60 to 70% are grass species. Another 15 to 20% are what we call forbs. Many people call them weeds. And then a small percentage, 10% approximately, are legumes. So you'll want to mix your cover crop accordingly. And the reason for that is we talked about aggregation early on and the importance of aggregation. Grasses have those fibrous root systems that will allow for more aggregation and build you more soil health. So we use cover crops as a way to get that diversity, capture solar energy. Now, with your cover crops, you want to capture as much sunlight as possible. One of the things I do when I go consult on a farm or ranch, I walk out in their fields and look at how much sunlight or pastures is hitting the soil surface. If there's sunlight hitting the soil surface, they've missed the opportunity to collect that solar energy. So that's wasted dollars, so to speak, because that solar energy directly equates to dollars in your pocket
Right.
if you use it correctly. So we want to make sure we have different heights of plants, different leaf sizes and shapes, different root types, rooting depths. All that lends itself to a healthy ecosystem,
Just like in nature.
just like in nature. All we're trying to do is mimic nature, called biomimicry.
Yeah. So, I practice permaculture on my farm, and we try to create this holistic ecosystem, this closed loop, right? Where we grow the crops, we have the orchard, we have the animals. And um, though I only have six acres, my entire property is on a hillside. And this particular portion at the top of this triangular shape that is my property was essentially, it was experiencing desertification. The soil was cracked. And this is before I even brought animals in. Putting animals on this soil that was already greatly deteriorated in a combination with 5 cover crops that I started mixing and planting every single season just to overseed after I read your book has done wonders. And I think, though I've only been doing this process for a couple of years now, I am already seeing a great benefit. But I think one thing that people often run into is they expect results overnight. And just like in nature, this is not something that we can expect. We have to slow the expectation down a little bit, that this is something that is up to nature and biology. It's going to take time, correct?
Yep. Yep.
Yeah.
So that's right. And I'm glad to hear that. The first thing that you have to do is you have to get carbon in the system. Now, you had some perennials growing there, and then you interseeded some annuals. Okay, I made the comment very early on that I could take a beech and turn it into soil. How would I do that? Well, the first thing is you have to cover the soil, you have to armor it with carbon. So what I would do in that case, I would go out there with old hay, some type of carbon material, and cover it, because you've got to protect that soil from warming up, and you got to provide the home and habitat for the biology. Then you can plant seeds in there. Now, in your case, you had the perennials there. So those perennials were covering the soil. So you had some biology. Then you added the annuals. They cycled more carbon energy through photosynthesis, exuded it, fed more biology. That started to cycle. Then you bring in the animals. You only eat no more than half of the above ground biomass. You trample the rest along with the defecation and urine. That jumpstarts the nutrient cycle. We can do the same thing in our garden though, without the animals. Just think of your animals as below ground livestock, your earthworms, etc. Where most gardeners make a mistake is they go in and rototill that garden.
Yeah.
That's the worst thing you can do. You're destroying the home for the biology, the very biology that's going to bring nutrients to those plants to provide you with nutrient dense food. You need to keep it covered. And one thing we want to do in a garden is we want to plant a cover crop when we don't have our vegetables growing. That cover crop needs to be primarily grasses and flowering forbs to attract the pollinator insects and the predator insects. But that cover crop then, that becomes our armor. We can lay that on the soil surface. We can do that a number of ways. Just walk it down, roll it down with a barrow, whatever the case may be. And so that's what you're trying to do. Cover that soil, jumpstart the biology underneath. Win-win situation. You start building soil.
So this brings me to my last question, I think, which is a lot of people don't realize that forageable cover crops are not only feeding the animal, they're feeding the soil. And you reference some really interesting and also somewhat disturbing information in your book about nutrient loss and how that just doesn't affect soil, that affects our food.
Yep.
And a lot of that has to do with synthetic fertilizers. Can you touch on that a little bit?
Yes, I sure can. And this is one of my passions later in life is I look at us as a society. We're becoming much less healthy. We're prone to disease. Look at the rampant rise in ADD, ADHD, Parkinson's, Alzheimer's, autoimmune diseases, cancer, the list goes on. I contend that at least part of that is due to the fact that we have a much lower concentration and array of these phytochemical compounds in our foods. And people need to realize that it's phytochemical compounds that feed our gut microbiome. Okay. When we consume food, we're not feeding ourselves, we're feeding the biology in our gut. And that biology then breaks it down, makes it available for our bodies. Well, our firm, Understanding Ag, is involved with some just groundbreaking studies right now where, along with Dr. Stefan Van Vliet, Dr. Fred Provenza, Dr. Scott Kronberg, we're going on to regenerative farms and ranches such as my own. We're comparing them with neighboring farms and ranches. And we have a team of scientists that come. They take soil tests. They start with the soil. What biology do you have in your soil? Then we look at the plants that are growing, and we grow the same type of crop, vegetable, fruit, whatever the case may be, on each farm. And we analyze those. We analyze the plant tissue, we analyze the fruit, vegetable itself, the grain itself, for these phytonutrients. And Dr. Van Vliet, using a mass spectrometer, can identify over 1,500 phytochemical compounds. Okay. Then if we graze those plants with either, a beef animal, a lamb, a chicken, whatever the case may be, we'll test the eggs or test the milk or test the meat to see the differences. What we're finding is there's not just a little difference, it's multitudes more, both in the array of different phytochemicals and the quantity of them. 2 to 10 times, 20 times more nutrients. way more than that as far as the array of nutrients. So what we're finding is that how healthy the soil is directly affects plant health, animal health, and now we're doing human health trials with it. And we're seeing a marked difference in human health in a very short time if they consume foods grown and raised on these healthy soils. So every one of you who grows your own food, and even those who are consumers, source your food from farmers, ranchers, gardeners who are using these regenerative practices.
That's absolutely fascinating.
It is, and we really feel that in the very near term, you will hear more and more of this, and this will then reach the point where food will truly be used as preventative medicine. You know, I contend, and I've said it for a long time, we don't eat food anymore, by and large, in this country. We eat food-like substances. Just read a label, it's junk, okay? Yet today, there's no reason we can't source nutrient-dense food. Go to your farmer's market, find your local farmers who are doing this, and purchase from them. And oftentimes, people are gonna say, oh, but it costs more. And I just say to that, what's your health worth? What are you spending on healthcare? Look at the average American now is on over 3 prescriptions. That's ridiculous.
That's crazy.
Yeah. Our son is 37 years old. He's never had a cavity, not a single one. And the reason I contend is look at what he eats. It's nutrient dense food. Okay.
Mm-hmm.
You know, we truly are what we eat, and we need to source our food accordingly.
And I think to piggyback off of that, this is Gabe's book, Dirt to Soil. It might be backwards for you who are viewing it. This has become my soil Bible, literally. But the piece that I'm referring to here is that you had mentioned if your grandmother ate an orange, it would have, let's see, I'm not finding it right now. I'm on the wrong page, but it would have something crazy, like 3 times as many nutrients or even more than that, 20 something?
Yeah, it was like you would have to eat 3 times as many vegetables, 4 times as many fruit approximately. Yeah.
Yeah. And that's just,
Today
yes,
compared to
today.
back then.
And that is
Mhm.
just a testament to what synthetics have done. And
Mhm.
then also the study of the 2 brothers that you had mentioned, where they're studying the amount of nitrogen that's being applied to the soil, and then their plants aren't able to absorb this over application. And so what ends up happening is the farmer looks at the plant, who is now wilting because it's getting an overabundance of nitrogen, I think was your example. And so they, as the farmer, they think, oh, well, it needs more nitrogen. And so they
Yeah.
just keep feeding it. And instead, it's not absorbing the nutrients
Yeah.
it actually needs.
Yeah, and so when I work with farmers, one of the first things we do is we do a soil test called a total nutrient digestion test. And
Mm-hmm.
currently we're working consulting on over 34 million acres across North America. We have not taken a single one of those total nutrient digestion tests that shows a deficiency in nutrients in the soil. So the problem, farmers keep adding nutrients. They're just, you know, they might as well take that check and take their family on vacation. Okay, it'd be more enjoyable. They're wasting that money. What's not lacking is nutrients. What's lacking is the biology to cycle those nutrients. And unfortunately, as we apply synthetic fertilizer, that biology becomes very lazy. The plant's able to access synthetic fertilizer very close to it. It becomes a weakened root system because it doesn't have to have this extensive root system to source nutrients. And it's a collapse of the entire natural nutrient cycle. So we're now in a production model where we just keep putting more on for no reason, and
Right.
it actually degrades the system. My farm in North Dakota ranch, we haven't applied a single pound of synthetics since 2007. Yet we're still able to produce crops. We still grow our livestock, all without that, because we rely on the natural nutrient cycle.
Right. Not only just coming from the air, but from the
Yep.
biology within the soil,
Yep.
the mycorrhiza, the protozoa,
Yep.
fungi.
And people say, oh, Gabe, you're gonna run out of nutrients. Really? When my roots can't make it to China, do you know how much rock is in the center of the earth? That all that rock is broken down. What happens? A plant, when it releases those root exudates, part of those exudates combine with water and form a mild form of carbonic acid, and that helps break down that parent material. Okay. 1,000,000,000,000 years from now, we'll still have plenty of nutrients in the soil. That's just a fallacy. Now, not if we keep farming the way we are
Right.
today, but
Right.
if we rely on the natural cycles, we're not gonna run out of nutrients.
I think the thing that offers comfort is essentially you're saying we can rebuild the biology, we can rebuild the fungi and the network within the soil, so long as we're planting the right things, cover cropping, completing the animal nutrient soil cycle, and then making sure we don't till and break up what's already there or use synthetics.
That's right. The
Yeah.
principles drive the processes.
Right. Right.
And
All
these
right.
are the same everywhere. You know, the processes are the same everywhere in the world. And I've traveled extensively around the world. They're the same everywhere. That's how come I can have the confidence to go anywhere in the world and get this to work. The crop species, cover crop species, livestock we use, grow and raise are going to be a little different depending on where I'm at.
Mm-hmm.
But the processes are the same. The principles themselves are the same. The tools are the only thing that's different. And by tools, I mean plants and animals.
All right, let's open it up for a few questions. I know we need to send you on your way here. Our first question is, what is your stance on hydroponic and similar agriculture? It sounds like food sourced from these types of operations would be unhealthy due to a lack of soil. What do you think about that?
And we have done testing on that, and unfortunately, it's correct. Because there's not let me back up and say it this way. There's more microorganisms in a teaspoonful of healthy soil than there are people on this planet. Okay? It's those microorganisms and the array and diversity of those microorganisms that cycle these phytocompounds to feed the plants. Okay, you're not going to get that in a hydroponic situation or in a greenhouse situation if there's not soil. Plain and simple.
Okay. Anastasia asks, well, she sends her love and thank you so much for your valuable insight. She loves the way you see the world. She says she wants to get your opinion on whether or not you have a recommendation for what is the best way to test soil and the water sources where you are when you're just starting out. She's trying to understand what possible toxins may be in the water and soil and what the soil composition is.
Yeah, and you can send a water sample to there's several labs and test them for toxicity. I primarily use Regen Ag Lab in Nebraska or Ward Lab in Nebraska, those two. You can test the water there for toxicity. For health of the soil, I like using what's called a PLFA test, phospholipid fatty acid test. Both of those labs also do those tests, and that's testing the living component in a soil. You know, oftentimes you see these garden centers, etc., or university extension. Oh, you can bring a soil sample and we'll test it. But they're only testing it for the inorganic fraction of nutrients, what's available that day. They're not testing it for the biology in the soil. I want to know the biology in the soil.
Yeah.
That's what I really want to know. So I use the PLFA test.
Okay. Do you believe it's possible for American farmers to completely eliminate synthetic nitrogen fertilizer by rebalancing natural nutrient cycles? And if so, what do you think it would take to get farmers to completely eliminate it? If not, why?
Great question. Can it be done? Yes, there's many of us like myself that have done it. Okay. Now, there's a couple things to take into consideration there. realize much of production agriculture today, well, all of it is based on yield. Farmers, they're told to produce more and more greater and greater yields, so they put on more and more synthetics fertilizers. That's degrading the ecosystem, okay, destroying the natural nutrient cycle. What we tell our clients is, let's focus on profit, because it is a business. Farmers and ranchers need to make money, and there's nothing wrong with making money, but we need to focus on profit. And what we show is that by reducing and then eventually eliminating these purchased inputs, they will have greater profit. So you've got to change the mindset of farmers away from a production model based simply on yield at a very low margin and price point, and one based on reducing inputs, going to a biological system that'll increase profitability.
Interesting. All right, I have 2 more questions today. Any tips for managing garden soil with noxious weeds? This person is dealing with creeping Charlie and ground ivy and hedge bindweed.
And the answer then is, why are those weeds there? There's a really good book out there, Weeds and What They Tell Us. Okay, there's another one, Weeds, Guardians of the Soil. Take a look at those books, but the creeping bindweed, and I'm sure what she's referring to there is creeping bindweed, is often a sign of compacted soil or bare soil. Nature, when I go out and observe on a farm, ranch, garden, I'm always thinking, okay, what's nature trying to tell me here? If I see a quote unquote weed showing up, the weed's showing up because something I did. And so typically those creeping type of weeds are an indicator of bare soil or very compacted soil. So what I would do is start planting grasses there and start to build those soil aggregates, alleviate that compaction, and make sure you have that soil covered.
I heard someone once describe weeds as opportunists. Perhaps it was you in your book, and it was just talking about how, if you see dock, for example, in your soils, that's often a sign of bad nutrient levels, and also it's too damp. And so you can sort of read the weeds, and it actually serves as a code. They're telling you something, which is just absolutely fascinating.
Yep, Weeds and What They Tell Us is a pretty good book.
Yeah, okay, I'll take a look at that myself. All right, last question today. Going off of the previous question about eradicating the weeds, where is the best place to start when reviving a field to bring in more birds and insects?
Yeah, and realize birds always follow insects, okay, as a food source, So the best place to start is with a diverse cover crop mix. If it is a field, a cropland field, what I like to do, depending on context, time of year, either a cool season or a warm season mix, and have species, flowering species that'll attract insects, in other words, the forbs, and then have some grass species. Often I like millets, birds like millet seed, etc., oats, barley, any of those grains, birds like that. But first you concentrate on the insects, the flowering species, have them in the mix along with some of those grasses, your numbers will expand. We're involved, one of my business partners, Dr. Alan Williams, is involved with a very large study in the southeastern US that they've been 4 years now in, where they're practicing these regenerative practices, moving livestock daily. What they're seeing is 4 to 10 times increase in the number of birds and bird species in just that short a time frame.
That's incredible.
Absolutely amazing. We're seeing the same thing here on the Northern Plains. Yeah.
That's awesome. And I think it goes without saying that well, maybe it does, but you might want to think about planting some perennials to create a shelter for those birds if you want them to stick around, not just fluctuate with the insect seasons.
Yep, those hedgerows would be great. Yep.
Yeah. Okay, we did have one last question, and then I'll let you go, Gabe, if you don't mind. Can crop farmers rebalance their nutrient cycles without livestock, or is livestock integration key?
Okay, great question. Get asked this one often because we deal with a lot of strictly grain farmers, and here's what I tell them. Yes, we can heal your soil without livestock. Okay, we can do that. Now, you may have to diversify your crop rotation, add cover crops, but we can do that. And I have many clients who have done that. However, make no mistake about it, you'd be able to take your soil to a whole nother level if you did integrate livestock. So yes, we can do it, but you'll take it even further if you integrate livestock. And what I always tell people is, maybe you don't want to have livestock, but I'll guarantee you there's a young person in your community who would love to have a chance to run some livestock on your field. So maybe give them a chance and help someone in the community also.
How do you feel about purchasing compost if that person wasn't able to source livestock?
Yeah, and realize there's a big difference between compost and fresh manure out of an animal.
Yeah,
I don't even really compare the two. They're different in so many regards. I'm not saying compost is bad. It's certainly a tool to be used. I use it more in garden type situations, smaller lots. It's just not practical, large scale production.
sure, sure. Okay. All right, well, that wraps up our Q&A. This has been such a privilege for me. Thank you so much. I've been looking forward to this since we emailed and you agreed to come on today. I thank you so much for donating your time and teaching everybody. Really, I'm just so thankful and honored to be able to speak with you this morning.
Well, thank you. The pleasure's all mine. And all I can say is it's going to take everyone. If we're going to change the current agricultural system and truly be able to provide our children, grandchildren, nutrient-dense food, all of us need to make a difference. Do what we can, educate when and where we can, and let's move forward. Thanks
Awesome.
for having me on.
Thank you for being here. And to everyone attending, thank you so much. This has been recorded. We are going to upload this to YouTube. I'm sure you've taken a lot of notes and maybe you didn't get everything, so don't worry, there's going to be a replay. Watch for that on the YouTube channel. Thanks again, Gabe. Take care.
Thank you.
Bye.